Okay, this is what I've got to, and let's um, let's show you how I think this should be interpreted. Um, so in the beginning, this was discovered, and this is the beginning of this incredible work of art. There is a line there which establishes that it's the diameter of a circle, and looks like it goes through various targets, including the ends of these various points. So we'll just darken that off and start examining what are three triangles. There are three and only three right angle triangles from here. So this is the first, and if you pop a circle on that, that will have the diameter, that will have a circumference that is the pi of the diameter, which is what the tangent value of this circle is. If we roll this circle down this hill to the other end, it will turn exactly 360 degrees. Now, just a point that I should have made at the beginning, apart from things like these animations, this circle, I've just drawn it on, every single line in this entire system, so all three puzzles, but this one obviously therefore as well, are generated from these two initial points, the G dot and the imprinted dot. There is nothing else, like, oh, you just drawn a line there. Nope. It's all generated by fairly simple, incontrovertible mathematical rules, and indeed those are the ones we're just going to demonstrate now. So that's your first triangle. This one is your second one, and that is a 3, 4, 5 triangle. That has been known to civilization since before we could write things down. But it is a representation, that particular, the rule of 3, 4, 5, and the generalization of it has been known for about 2,000 years, I think. Now, this thing forms this yellow on the bottom, so this third triangle. So there are three and only three triangles on this, right angle triangles. And this third one, at the bottom of it, forms a divine portion with that. And what that means is that if we go and whack a perfect pentangle on there, then this line is the same length as this line. Now, there are so many different places that you could put two extra circles on here, that we're going to have a bit of a beauty contest on that one as to exactly where they should go. They may just be each on the small side. I mean, circles that are related by phi will do lots of fractal-like things, but that's the we have three triangles, three-sided, obviously, right-angle triangles at the start of this, and as I say, sorry, that line equals that line. So okay, so now there is two construction lines now I need to show you. This is the the horizontal line from the G dot, which just so happens to unerringly see through these two dots here, and we'll just terminate it on the circle because we don't need it anymore. And there's this other line that goes from the phi triangle, as I call it, this bottom one, up to the pi triangle, and they intersect exactly where the we'll call this a thought dot for now is. So that's a little bit of work that we have to do. Now there's two extra construction lines that we need to draw first. This line will terminate that line. This line is defined as horizontal from the pi triangle. Right? Now this line touches this, but we've no idea yet where this is supposed to be because there is not a triangle on this side. What is it that nails that? And so the final concluding, ending construction line on this diagram is that line there, which goes from the 345 triangle through this intersection that we just created and then onto this line which we've just created. And that's it. There are no other construction lines on that that have any meaning. So what's particularly delicious about this ending line is this, at London stuff. Why does it say at London? It doesn't say at London. Well, these two, that's the first. This is this is the original line. This is the generator, and as I say, of everything, right? And then that for this part of the this puzzle is the concluding line, the beginning and the end. So let's just zoom in on that. So there's just a little thing here with the A, and where that is. That line goes to where the upper line ends. This is where it's mathematically predicted to be. I'll come into that a little bit later. There are actually two frames of reference that are very, very slightly different. But it's this thing that I really want to talk about here, where we have the beginning and the end that are going through this T. Now, what's the big deal about that? Well, let's just sort of note that we're getting bullseyes on what. I've got this thing about serifism, and there's a notable full stop that's been created on that. I have inquired for a super high-res version. This is far too pixelated, obviously, to be able to get any further. Now, the big deal about that, of course, is that A and T, Aleph and Tav, are the first and last letters of the Hebrew alphabet. Alpha and Omega are the first and last letters of the Greek alphabet. When they translated I am the Alpha and the Omega, I am the beginning and the end, it is my signature, and all that stuff, into Latin, they should have said I am the A to Z, but they ran into copyright issues. So if you don't find this geometric beginning and the end, if that's not floating your boat, it is mine. Now you may notice here on this, because it's quite notable now, is that, well, your blue dot, mate, it's nowhere near this dot here that you're talking about. So what's all that about? So that is the Aspley dot anomaly, because it's just not where it should be. But yeah, it has got something very suspicious on there, and I'm very sorry, but that is a pyramid, that is a triangle, and that then puts us in spookily accurate. We're not looking at the size of that, we're looking at this. Distance is 2/3 of not a lot. Now, I'm told by Wikipedia this is not a Masonic symbol. The all-seeing eye, nothing to do with masonry. There is quite a lot of building work going on here. I don't care. I realise that as soon as you come in with this, you're Eric von Daniken. It's on the bloody money, right? I mean, you'll work out whether or not, it's Masonic or whether or not it's just knowledge. These angles you are going to find out are 51. Yes, they have machined that to 51. They've filed it down on lines that go much further, and they've measured accurately, and then they've done as best as they can to get those to 51 degrees. So that's it. That's the first of the three puzzles, and the discoverer of this was Alan Green, and all of these lines here, and any kind of interpretation of that part, Alan was very well aware of. There's a lot of other stuff on there, and I'm sorry to be so brutal about it, but they're all wrong. I haven't added onto this because an absolute demolition of everything, but you have, I'm afraid, Alan, really screwed up by just carrying on and coming out with numbers. I can make loads of numbers turn up out of here just by sticking it all into a computer and churning them out. I've got a Knights Templar golden triangle saltire, if you want it. It's not. All right? They're not perfect golden triangles. These are perfect golden triangles. So there we go. So now the whole point of this, that's what the job of our first little game here is to generate that bottom rule, which is, as I say, horizontal, and I'm utterly certain that it's horizontal. So that we can move on to the next level, the next stage of the game. So here is the next stage of the game, that blue line forms a box, and in that box, this is all geometric consistent, but we get 51 degrees. My program, if you like, 51 is one of the numbers. I need to know pi. Root 5 plus 1 over 2, which is phi, is just part of geometry. But 51, what's 51? Well, it's 3 times 17, which is extremely nice, right? I like 3 a lot, and 17 is very, very, very handy. But it's also just under, but it's a meaningful rounding of a certain building that we've already bumped into. So that's our pyramid of Giza, and so let's just go and look what we've got in this box. And of course, as you may have seen on a previous presentation, we have 2 equilateral triangles there. And then this line down the middle ends up at the 6. That's a vector line from out of GIMP, the GNU image manipulation program. Don't worry too much. And this is actually a guideline from the center. And if you look at the size of that, I mean that's we're right in the middle, within pixels of whatever could be the middle. And as you can see, that's been so deliberately made. There's a donut there and an inverted full stop. And then we've bullseye. And then we've also got this. You say, well, okay, you just drawn a triangle. Yes, but it's through the very centers of each of these S's, these 5 S's. Now, I've got this adorned, this 6 here, which is well, it is a Masonic number, but it's just the way they've done it, as I just showed you with that. I've been saying crucifix. I do apologise. A crucifix is only a crucifix when it has Christ on it. So a cross of religious intent. I reckon that is, but head office need more. But we'll see. If that's not part of this. Now. These circles have just been plonked on there for an animation. If you're complaining about they're not perfect. But we've got a circle there, obviously. We've got a circle there, and we've got a circle there. And as I said, it needs to do a little bit more work on the animation. I think that it just hits there. I think these 3 are supposed to be coincident, but I'm a little bit too bushed to go through that. So we've got 3 isometric triangles, and of course we're going to have 3 of these pentagons So that's the first one. And so we find out now that the A's are in fact golden triangles. Oh, really? And both of these A's, this serifism is key. So we say, oh, you haven't really hit it. No, no, that's a bullseye in my book. I mean, obviously we've rolled up either side of it, so then we can say that that's one's coincidence, but that is a score. If you've been following the rules, which have clearly evolved from looking at this with precision. And I stress again, every line that you've seen so far is generated from these two dots, notwithstanding the caveat that this line is in fact, what's actually happened is these two dots are about 1.5 millimeters too far away from each other. And I'm getting down to the bottom of how they managed to kind of miss that. So we've now moved on to the frame of reference from the exact ends of this line as it's actually on the page, but as you can see from the previous one, it's like, well, it's near enough, isn't it, mate? Well, not quite near enough for me in order to be able to do the precision that you're looking at. Now, we have, of course, got another one, and that's bounded at the top by these two triangles, which is good, but it's also bounded underneath by that, and so the pair of them define geometrically what this has to be. All this stuff, the bottom, the previous pentagon just comes out of the square. These ones are all dependent essentially on the height of the pyramid. If you change the pyramid, then these change. But there's nothing. This is something I had a very, very serious argument last week with someone who's essentially a brother, and he just hadn't realised that this is all done geometrically. You just draw lines. I haven't. This could all be done blindfold. I mean, his argument was actually about the artwork. You just pick, because it does. I mean, it just so happens to go straight through the eye of this and points the little girl on the nose. Now, I know that the hairs are associated with the De Veres, but for the rest of what's going on up here, guys, you're on your own. I have no idea. Please start explaining to me, please, what I've got this thing to point to. And then, of course, we have our third. We have three. It was always three. And this one, again, is derived. See these two intersections there and there and there. Oh, fantastic. So we've got three of these things. And, of course, that means we've got three circles, haven't we? Isn't that fantastic? And we're going plonk, my logo that I've kind of invented on there. Now, the only trouble, excuse me, the only trouble with what we've got so far is that we've got 3 pentagrams and 3 isometric triangles. We've only got 1 square. There are 2 more squares. If you want to find them, you can do. I'm going to have a rest for a bit because I've spent the last 2 weeks very, very involved. So there we go. Here's a square. So we're suspecting that the O needs to turn up in a square, but it needs to be geometrically. You can't just plonk them on there and go, oh, look, it fits. I mean, we can do it for a laugh, but in terms of it being part of this, in terms of it being the missing 2 squares, I have to be able to draw it just, as I say, blindfold, if you like, just from using geometrical rules. It's not like, well, if you line it up here. So I wasn't sure if the H was one. I don't care if it is. We need to be able to. If it is, we need to be able to define the H. I don't think that's that. But anyway, there's 2 squares in my opinion to find. I do love my logo. You see, there's this V here, and then there's an obvious V underneath there, and I don't care what you say. I mean, 2 V's, de ver, is we have it in his own hand that he uses that, and in fact that's part of your Vivilium. shake-spear stuff. So good. So let's go on to our third. So we have to go back to the beginning, and our line, those 2 points generate everything that you have seen. So the only caveat is that they are slightly too far. So this line that it generates here is, well, this one is a little bit too short, but so is that, and so is that. The three fixtures are all totally consistent with each other. They got these two slightly wrong. I mean, it's 1.5 millimeters. I mean, everybody's been going, oh, you can't really tell a millimeter. Fine. I think they can actually, but why they screwed up, I don't know. I'm still sort of rooting around on that. I mean, it's not that bad. So that, if we reflect that, we get we get kind of an X thing. It actually points to some cryptography, which I will mention in a moment. Let's just get on with the shape. Now, if we draw a line from the 9 dot, now here again, this 9 dot is a little bit to the right, and that's because it's lined up on the eye, even though it's on the circle. When D drew this to massive scale, that's what I suspect the eye has something to do with this. I'm not sure that we've quite finished this final one, but I don't want to butcher it in any way. But we've got that to the eye, and I reckon that this is a cross of religious intent that goes through the shakes and from the little girl's nose to the 6. I don't know if they're part of this as yet, but I need 3s of everything. So maybe we've got, well, okay. So we now have here a Petrine cross. You cannot, by definition, be a Petrine crucifix mark. And this point is really rather important now. So we'll just put the circle on there. That's one of my circles. You may be wondering at this point. So we've got a 9 here. So I'm sure you know what the mathematical properties of 9 are. What other 3 3s we've got in here, we'll have to see. But this is 9's obviously featuring on this particular third of our 3 puzzles of 3 3s. Now, if you rather arbitrarily plonk the columns of the south transept of Westminster Abbey on there, and you might go, well, where did you get that from? Well, it's in the next page, which was solved 6 years ago. So do keep up. I will be returning to the Cardano. It needs further collation, in my opinion. Now, that point is the altar of St. Glade's Chapel, amongst other things. And there's a wall along here, but it's not between the 2 columns. It's to the side, in order that the altar of St. Glade's Chapel is not built on top of, which is interesting. And that's the object. Let's go back to that. That point here is in fact what all of this is about. This is a treasure map. So at this point we can now conclude this triangle down here with this D in the middle is evocative of. You may be wondering where the missing pyramid is. So here it is, and yes, I'm afraid so. Now I've inquired to the British Library, as I say, for what this is going to cost. We might need a whip round because it's going to need special. It's not an ordinary one that they would do. But I think in the circumstances, we really need to get right down to the bottom of these matters. Now, we've got a huge glyph-sized dot here, which I have to say does have something there which I'm intrigued by, but I just want that. Forget that. I've no idea what that is. We've got a circle here. It's so big. I'm counting that as my circle. Now, this triangle is evocative of a delta, and it's got a D in the middle of it, and that is my dot. And that's why I have this at the end, because the D signs this, and with delta dot, which he does. That is his signature, incidentally. If you were to, he does use a delta and a dot. The other way around, but he is also very fond of reversing things in his puzzles, but that's a full stop to end these three amazing things. And I say again, every single one of these lines that you see is generated from these two first points. Every single one of them. And so there is our Trinity. We have the three elements. Kepler refers to Pythagoras and the divine portion in a quote which the Freemasons really do love. If you stick that in looking for it, it'll turn up on kind of elementary Freemasonry websites. Many of them run by the Freemasons. So that's all rather pretty. That's my logo for the pentagram party that we've got up there. And then this is our sacred thing, which is there's probably a little bit more work on this. We've only got two circles for a start off, so a bit of thinking there, and yeah, two squares are missing from upstairs that we need to have a think about. And so, that's it for now. I just need to make it something clear about this guy, and really put sort of page 3 of this document, which I have yet to get to, and I have no compulsion whatsoever to read it, other than to get to the bottom of the cryptography. Hardly anything that this guy ever wrote means anything to me, I'm afraid to admit. I mean, some of it, this England stuff and everything, it's not like nothing, but in general, it's very, very hard going. I'm not going to bore you with what I was doing beforehand, before I got into this last year, but I was north of Hanover on the 15th of April, 1945. It's very, very difficult to look at. It's arguably the most important day in the modern definition of your country. This now deeply haunting painting, which is of De Vere, I'm quite convinced now, as are others more scholarly than me, is really haunting me. This, over the course of the second millennia, is the most important man in your history, and that's really all I'm here for. I just want to know who I am. So I'd like you to take some notice. These two lines here have been known for or used for 3 centuries or more as a device to indicate anonymity. And I have that on very scholarly authority. Why has that happened? Why has all that happened that I've just shown you? It's a work of sacred art on this front page, and on the second page. The second page is mind-blowing from a computational point of view. It's all letters, don't have to do any jam, but in order to prove that you can't do it with mathematics, but I've been throwing humongous amounts of text and at some of these things just to show you that they don't turn up anywhere. So that's your lot for now. I need to have a bit of a lie down.